Hey Calculus class, today we are going to talk about topic 63, alternating series. So an alternating series is if the terms alternate between positive and negative. Then we say that the series is an alternating series. So usually the series will have some multiple of a -1, such as this one. So that means that it would alternate between positive, negative, and so on. And of course, where a sub n has to be greater than 0. And if a sub n is greater than 0 and with decreasing terms, and the limit as n approaches infinity of a sub n equals 0, then we can say that the alternating series converges. So what this means is basically if I start out at my starting point, which I'm going to say is 0, then I add my first term, a sub 1, I get my first sum, which is s sub 1. Then from here, I'm going to add a sub 2, and since a sub 2 is smaller than a sub 1, then I'm going to come back this direction. But since a sub 2 is a negative term, it's going backwards. Now I have my second sum. And now I'm going to do this again, but this time I'm going to add a sub 3, and then I get my third sum. Then I'm going to subtract a sub 4 to get my next sum, and I keep doing this. So basically what's happening is that this series is vibrating or jiggling around some sum s. So that's how I know it will converge. So if we were to look at an example, so if we wanted to figure out if the series -1 to the n plus 1 over n converges or diverges, I'm first going to look at just the a sub n, so the part without the -1, which is 1 over n. And so I'm going to first do my divergence test. So that means I'm going to take the limit as n approaches infinity of 1 over n, and I get 0, which it's supposed to happen. Then I have to determine, do I have an alternating series? And yes, I do, because I have a multiple of a -1. Now I need to make sure that a sub n is positive. So if I was to list out the terms of a sub n alone, yes, I would get just positive numbers. Then I need to check to see if those terms of a sub n are decreasing. And I need it to be decreasing so that it does that jiggling back and forth around some sum. And 1 over n is a decreasing sequence. So since all of the checks are yes, and the limit is 0, then we can say that this alternating series converges. And note this specific series is the alternating harmonic series. So just our typical harmonic series we know diverges, but the alternating harmonic series converges. All right, so now let's take a look at this one. My a sub n is 1 over it cubed plus 1. I'm going to first check my divergence test. So when I take the limit as n approaches infinity, do I get 0? Yes, I do. Is this an alternating series? Yes, it is, because of the multiple of -1. Is a sub n always going to be positive? And yes, it will if I just keep listing out the terms. And is a sub n decreasing? Yes, it is. So we would say that this series converges because of the alternating series test. Now when you're doing this, and at any moment in time you get a no to one of these, that means you need to go to a different test. Even though it may be an alternating series, if a sub n is not positive or a sub n is not decreasing strictly for both of those, you need to go to a different test. All right, so now let's look at the error bound of alternating series. So we can estimate the sum of an infinite alternating series by adding up the first m terms and ignoring the rest. So this is basically a method to figure out what does the alternating series converge to. So what this means is if I have some sum, that's sum m, and I have my true sum, then if I was to add the next term, I would be adding a sub m plus 1 to get the sum m plus 1. Now this distance between this sum and the actual sum is represented as the absolute value of s minus s sub m, which needs to be less than or equal to a sub m plus 1. And as you can see here, this distance is less than this term. So this basically means that the size of the error is smaller than the absolute value of the first neglected term. So the first neglected term would be the a sub m plus 1. So let's take a look at an example. So we want to first calculate the first 10 partial sums of the series and graph both the sequence of terms, the a sub m, and the sequence of partial sums on the same screen. So you'll want to do this with the graphic calculator. And we want to estimate the error in using the 10th partial sum to approximate the total sum. So what that means is I'm first going to list out my first 10 terms of this alternating series. So when I list out the first 10 terms, I get the following. Notice they're alternating signs. Now I'm going to list out the first 10 partial sums. So I'm doing that by the first partial sum is just adding the 1 to itself, and then the second one adding the first 2, third adding the first 3, and so on. When I do that, I get the following. And I put them in decimal form so that I can more visually see what value the sums are converging towards, if they're converging. Now, if I was to graph these two things on the same screen, I would get a graph that looks like this, where the blue represents a sub n, and the green represents the s sub n, the partial sums. And as we are getting closer to the 10th term, you'll notice that it appears that it is converging to something, because the first couple terms right before the 10th term, notice that the first 2 decimal places are not changing anymore. They're all 0.90, 0.90, 0.90. So that's telling me that the partial sums are starting to converge towards something that starts out with 0.90. So basically I would then say that this sum is approximately 0.90112. And in reality, I don't even need to put the 112. I know it's going to be at least 0.90 something. All right, now let's take a look at this example. How many terms of the series do we need to add in order to find the sum accurate to 2 decimal places? So here's the series I'm going to look at. And since I want it accurate to 2 decimal places, this means that the size of the error needs to be less than 0.001. So basically, I don't want the first 2 decimal places to change. So if I list out so many terms of a sub n, and in this case I listed out 7, then I go ahead and I list out the partial sums of the first 7, I get the following. And if I look at the partial sums, you'll see after the third one, the first two decimal places are not changing. So I got 0.94 something, 0.94 something, 0.94 something, and so on. So how do I know which term I can stop to figure out the sum accurate to two decimal places? Well, that's where we have to check to make sure that the size of the error has to be less than 0.001. So that means I'm going to look at the absolute value of a sub 5, which is 1 over 625, which gives me approximately 0.0016. And then I'm also going to look at the term after that, which would be a sub 6, and I would get 0.00077. And the a sub 5 is bigger than 0.001, but the 0.00077 is less than 0.001. So what this means is that since the sum of the first 5 terms is accurate to two decimal places, to the actual sum, and the error size of 0.00077 does not affect the second decimal place, we will use the first 5 terms in the series to estimate the sum. So how did I know to do a sub 5 and a sub 6? I just basically picked 2 terms next to each other and checked to see if one term is bigger than 0.001 and if the next term is smaller than 0.001. If that happens, then you can disregard the next term and you can stop at the a sub 5. So now I can basically say that the sum of this series is approximately 0.94. And it could, and I know it will be more, but I know it's at least 0.94. All right, well, I hope you enjoyed learning about alternating series, and I will see you in class tomorrow. Have a good night.